Hello, and welcome to the Global Climate Lab. This lab was created by the University of Idaho Department of Geography, but I have modified it to fit our needs. So, global climate. Climate is defined as the typical conditions for a location determined by calculating averages of weather observations over time. The climate for a region is controlled by many factors, including latitude, elevation, ocean circulation patterns, local topography, and prevailing winds. The climate for any given location has changed considerably over the last 4.7 billion years, and it is still changing. We measure this change by looking at trends in paleontological proxy record, or the paleo proxy record. In this exercise, you will explore the distribution of climate regimes across the Earth's surface. You will also make observations about climate trends from tree ring cores. So there are three parts to this lab. There's a part one where we calculate climate using temperature data, and we calculate it from data from the Pullman Airport as well as the Lewiston Airport. Part two, we look at a tree ring core sample. That's a paleo proxy record. And part three, we look at climate records, not in Google Earth. I'm deleting that right now, but they're climate records in ice cores. So let's go back up to part one again. Part one, climate is determined by a variety of global factors, but it is observed through the day-to-day collection of weather information and subsequent analysis of that information. If you watch the weather on TV or look for weather forecasts on the internet, and the forecast says it is going to be 5 degrees hotter than normal or drier than normal for the month, the forecast is using a very carefully calculated version of normal. This version of normal depends on how many years of data are being analyzed and where the weather recording stations are located that contribute to the data set. For example, while there is a weather recording station on campus, the nearest one used by the National Weather Service is not the one on campus, but at the Boise Airport, because we're in Boise area. But for the University of Idaho, it's the Pullman Moscow Regional Airport, which is several miles away. The map on the next page shows two local weather recording station locations, one at the Pullman Moscow Airport and the other at the Lewiston Airport. Most official U.S. weather recording stations are at airports or remote locations in the mountains, not in the populated suburbs and rural areas. Instead, weather forecasters use the closest stations and calculate the predicted conditions between them. And they use a variety of methods to do that. You might observe consistently different weather at your house than what the National Weather Service or your local weatherman reports for your area, which is definitely true at my house, which is why I have my own little amateur weather station, because it's always hotter where I'm at. So you go through the worksheet and you calculate average high temperature for June of 2008 for each station, and then you calculate it for the average high temperature for June over the past 30 years. And here's the data for that. And then you're asked several questions about the data that shouldn't be too difficult to answer. And then here's this graph with a trend line here. I use this trend line to make some predictions on what weather should be like a couple of years out from the data. So in 2010, which is in the past now, but it was in the future in the past. Using this line, the equation for this line, that's how you make those predictions. And they give you blank spots to fill in, and here's the slope and the intercept. So hopefully you can just use that equation for the line and get these answers. And then part 2, reconstructing climate with proxy records. In the first part of the lab, you calculated a climate normal from observations made at weather stations. In trying to reconstruct historic climate, we don't have observations for most locations prior to 1900. So we have to find proxy or substitute records for weather conditions in some other fashion. One of the best proxy records available in climatology is tree rings, dendrochronology. Tree growth is dependent upon temperature and precipitation, so tree rings are wider or narrower depending upon the conditions for a given year. Since trees only normally add 1 ring per year in our climates, we can easily date trees to link the climate conditions to the year they occurred by counting, right? Another climate proxy often used is an ice core. These cores drilled thousands of meters into ice caps in Greenland and Antarctica give climatologists a different and much longer scale view of how climate has changed and how the atmosphere has changed over time. You'll explore some ice core sites in part 3 of this lab. In most of the western U.S., tree ring width is indicative of whether it has been wetter than normal year or drier than normal year, or a precipitation normal year. In the example below, 5 rings are highlighted, and then you get to look at each of these highlighted tree rings to determine which is wet, dry, or normal. And here's some data to do that. So here's the normal years, and here's a wet year and a dry year. You get to answer these questions. So in the quiz, I've definitely made the correct answer very different from the wrong answers. So don't sweat about like 1 millimeter difference, because you should be able to figure out which is the correct answer in the quiz if you're like plus or minus a millimeter, or plus or minus a year. And here we are on to part 3, proxy climate records and ice cores. And so in this section, we will look at some of the areas on Earth where scientists are drilling deep into ice caps to obtain important climate information from ice cores. This important climate information includes atmospheric concentration of gases such as carbon dioxide and methane that affect our global climate. These gases are generally measured in parts per million, ppm, or parts per billion, ppb. So what does ppm actually mean? Just as percent means out of 100, so ppm means out of a million. 1 million is equivalent to 1 milligram of something per liter of water, milligrams per liter, or 1 milligram of something per kilogram of soil, milligrams per kilogram. For this lab, you can assume that ppm is the same as parts per million by volume, ppmv. So by measuring gases trapped in ice bubbles for long periods of time, we can understand how industrialization has affected carbon dioxide and other critical greenhouse gases. So go to these 2 different websites to answer the following questions. And these questions concern about what has happened over the past 800,000 years, which is a much longer time span than the tree core record, which is just hundreds, thousands of years. So here you go, you answer these questions. And once you've completed the worksheet, then go ahead and take the quiz, the Climate Lab quiz, to submit your answers. And if you have any questions about what's going on in the lab, please do not hesitate to email me. I will answer my emails on a daily basis. And good luck.